we are going to discuss the concept of spread spectrum modulation or communication. Now let us going to define here spread spectrum communication. So it is the technique in which transmitted sequence occupy much more bandwidth than the minimum bandwidth required. So intentionally we are going to increase the bandwidth of the input signal in this case, which is quite disadvantages, I would say, because it will consume much more space in the channel when it goes, but this will provide us the security of the signal. In another words, we can define it is the technique in which we are spreading the data at transmitter and we are dispreading it at the receiver. So intentionally what we are doing, we are going to spread the data at the transmitter. Now how we are spreading the data? So a single bit is going to be converted into the multiple bits. How? So let's say for example we are having this single data. Let's say this is 1 and this is 0. So it may have certain time period. Now we are going to decrease the time period of this signal. It means we are going to increase the frequency of the signal and hence the bandwidth. So this signal is now converted into a high frequency signal and therefore high bandwidth signal. So a 2-bit signal, 2-bit signal is now converted into 1, 2, 3, 4, 5 bits. So this is how we are going to spread the bits into the multiple bits. So which here we are intentionally increasing the bandwidth of the data just for the security purpose. Now who is responsible for spreading the input data into multiple bits? So to do this, PN sequence generator is responsible. So let us have a look on PN sequence generator. A PN sequence generator is as shown in this slide. It is composed of some of the elements. It is composed of a logic circuits like XOR gate, some of the shift registers, I would say flip-flop. These are the shift registers. These are memory elements, I would say, for storing of the digital data, and output of each shift registers are connected to the are given to the next shift register. This is how the connection is supposed to be there. To each and every shift register we are applying the clock circuitries. Output of every shift registers we are giving to the logic circuitry, and output of the logic circuit we are give it to the first shift register. So this is what the construction of the PN sequence. A PN sequence is basically a very high frequency signal and it appears like a binary pulses. The sequence is not completely random but obtained by some well-defined logic, and that's why it is called as pseudo noise sequence. The PN sequence can be generated by using this feedback circuitry, and the constructions I already told to you. Now depending upon the output of now how many bits are there in the PN sequence? So it depends upon the number of shift register. As you can see, the how many number of shift register here, we may use m number of shift register. So the total number of bits in the PN sequence may be up to 2 raised to the power m. So if suppose we are using only 3 shift register, it means how many bits are there in the PN sequence? Total 8. Now one more thing we need to keep it in our mind, that we can't consider all 0 bits in all shift registers. So all the shift register must not have 0 value. If all shift register, let's say shift register 1, 2, 3 and m, all shift register is having 0 value, then they produces 0 output at the logic circuit, and this 0 output will be once again given to the first shift register, and this process will goes on, or it will continue, and we can't come out of this particular stage. So the operation will never finish. So what does it means? We are not supposed to stuck this design into the zeroth state, and that's why the total number of bits in the output of PN sequence is not 2 raised to the power m, then it is 2 raised to the power m minus 1. So what is why we have written minus 1? Because we are avoiding all 0 values in the shift register. So apart from all zeros values in the shift register, we may consider any number of values. This is how the PN sequence generator will provide us the PN sequence. Now, where to provide the tapping? So the next slide is feedback tap for the shift register. So basically, where we need to provide the tapping. So it depends upon the two conditions. These are the two important conditions. While considering this, the tapping is supposed to be provided, and it is as shown in this particular table. So what are these two conditions? The sequence, the PN sequence must be repeated after certain duration. So this is what the first and important condition. PN sequence must be repeated after certain duration. After some bits, 3 bit, 4 bit, 5 bit, 7 bit, it must be repeated. And the next condition is the occurrence of ones in PN sequence must be at least greater than 1 to that of the occurrences of zeros. What does it mean? If suppose we got the PN sequence, let's say 1 0 1. So in this sequence, total number of ones are 2 and total number of zeros are 1. So the number of ones are at least greater than number of zeros by 1. And to get this, we need to provide the tapping. So basically, this is what the way we are providing the tapping while considering the previous mentioned two conditions. So here I am providing here some of the designs uh, for the PN sequence generator, which have two shift register, then three shift register, then similarly four or five shift register. So in these two cases, five shift register. Now if the total number of shift registers are 2, then we can provide the feedback taps at 2 and 1. So what do you mean by 2 and 1? So this is what the basic diagram, and we are providing tapping at 2 and 1. 2 and 1 means we are providing output of first shift register and second shift register, and we are connecting it to the XOR gate. So output of first shift register and second shift register, it will goes to the XOR gate. Now if there are three shift register, then feedback taps will be provided from third and first shift register. So from the third shift register, an output of first shift register will go to the XOR gate. Now if similarly four shift registers are there, so output of fourth and first shift register will go to the XOR gate. Now if there are five shift register, then we may provide either of these three ways. Either we provide output of 5 or 2, or we may use this combination 5432 or 5421. 52 is very simple, which we have earlier shown here also. Now if it is 5432 or 5421, how the design is supposed to be look like? So if it is 5432, then it means we are providing output of fifth shift register and fourth shift register to this XOR gate. Now output of this XOR gate is once again given to the another XOR gate from where to which the output of the third shift register is coming. Now there is one more output which is coming from the second shift register. It is to this XOR gate, and one more input to this XOR gate is from the this XOR gate, which having the output of third, fourth and fifth shift register. This is how we are providing the tapping of second, third, fourth and fifth. So if we are providing tapping of the four shift registers here, 2, 3, 4 and 5, it means at least we require 3 XOR gate. Similarly, if we wanted to use this combination 5421, we may use this way. Output of 5 and 4 first of all combine here, then this combination is then coming here, where the another input is from second, and then the total is coming here, and the another input is coming from the first shift register, and obviously output of this shift XOR gate is coming to the first shift register. This is what the tappings we are supposed to be providing. In most of the cases, we are getting the design which having at least 2, 3 or 4 shift registers. So this is all about PN sequence generator. Now in the next uh, session, we are going to look at how to solve the problems based on the PN sequence.